should work on there. That's the exponential. I probably don't even have. All right, number 2 with the logarithms. This is just rewriting them, so it shouldn't be too bad. Some of these are on your test worksheet, by the way. I'm not going to... Y'all know how the test worksheet right now. Oh, man, she cut them off again? How does it keep getting cut off? I must do something formatting. I believe number 2 is the first one you show your work on. Okay? Number 2 should be the first one you show your work on. So that left upper corner should be 2. So this is the one you show your work on. So to change this to a logarithm equation, it would be log base 4. The exponent is over here by itself of 1. So 4 to the 0 power is 1. 4 to the 0 power is 1. So you could just write both of these on your show your work page, and that's fine. On the next one, same idea. This would be log base 6. Oh, no, we're trying to go from log to exponential, right? So base 6, the exponent is over here by itself. So 6 to the negative 2 is 1 over 36. I believe that Alex is going to make these make sense. Like, they're not going to give you something that doesn't make sense. 4 to the 0 power is 1, and 6 to the negative 2 is 1 over 36. So like, you can kind of check your answer to make sure it's right. The next one is on the show your work page as well. So it says evaluate each expression. I think this one I put on here just more so to see how you're doing it. So what a logarithm's saying is 6 to what power is 6? So for A, it is saying 6 to what power is 6? 6 to what power is 6? If you want to rewrite it and put an x there, this would be 6 to the x equals 6. So x equals 1. Okay. For B, this is saying 4 to what power is 1 over 64. So this is saying 4, put an x here if you need to, 4 to the x is 1 over 64. Well, 4 cubed is 64, and then how do I get it to be underneath? Negative 3, right? 4 to the negative 3, you make it positive, would be 4 cubed over 1 over 64. So all you really need on your show your work page is... I don't know. This is what I want to know is like, how well do you understand logarithms? If you really understand logarithms, you can just write this on your test work page. Okay? You could just write all this on your test work page and have your answers. But if you need to, but I want to know, do you really understand them like that? Or are you transforming them and putting this on there? Okay? So it's really just dependent upon what you are and how comfortable you are with logarithms. Graphing the ln of x, I'm going to go ahead and do this and then I'll write it out. But the negative 2 on the inside would move it to the right 2. And then the negative 3 on the outside would move it down 3. The starting point on logarithms, this is natural log, but it's still the same thing. The starting point on logarithms is 1, 0. So everything is based on this point 1, 0. And then we are going to move it to the right 2. And then we move it down 3. Okay. So this one, you always do the opposite. So it would be opposite of what you think on the inside. So it's down 2. And then on this one, you move it. See, y'all got to stop me. You move it to I got everything written out, right? I just wrote down. When you move it to the right 2, you do the opposite of what you think. It's negative 2, so we go to the right 2. And then on the outside, it would be down 3. Okay. Y'all remember those transformations a little bit? I know y'all were fixing to tell me to change it, weren't you? So here you have to do the log properties. There are 3 log properties that we have learned, or that we do. The first one, when you see subtraction, you think division. So this becomes log base 2 of 3 over 5. So I guess all you have to write is a 3 over 5. That would be my answer, 3 over 5. Oh, I'm sorry. Number 4 would have been on your test work page. We'll go back to it in just a second. Number 4, we skipped it. Let's finish this one. We'll go back to it. On this one, when you see plus, this would be multiplication. Multiplication goes together. So they kind of give you the answer. So this is saying 10 times what number would be 70? So this would be a 7. So when you see addition, you think multiplication. 10 times 7 could be 70. And then the last one is like a little bit of the weird one. I could rewrite 25 as 5 squared, right? And then this 2 can move up here. So you can move those. Or actually, I'm going to take this 2 and write it down out in front. So you could rewrite 25 as 5 squared. And then when you move it out in front, this would change this to a 5. So that one you do have to think about that this number is like, if I moved it up here, it would be the squared. So what number squared would give you 25? And that would be 5. All right, just to go back to number 4, because I accidentally skipped the work page. All I want you to do on that is you are writing your transformations. So you would just write what I have up here, okay? So this stuff up here is what you would write on the test work page. I want you to write the equation and then tell me which one moves it right, which one moves it down. You don't have to draw the graph or anything. If anybody's got, I was gonna say, if you got Canvas, pull up the test work page to see what that bottom left-hand corner one's supposed to be. I'll probably remember when I get there, but so number 6, the rest of them are just show your work. So show this one on your test work page as well. Most of y'all have been using the test work page as your like scratch paper and using the back of it and stuff, which is good. It's a good idea. I didn't intend on y'all doing that, but that's awesome. So on this one, we want to expand it. So we want to write multiple logarithms. So this is multiplication. So when we see multiplication, we think addition. Okay, we think addition. And then when you have a 9 up here, you can actually change that and put the 9 out in front. And that would be what it looks like expanded out. The next one, again, you are going to expand it out. It's just a little bit of a harder one. But I mean, you can really do these in one step once you get the hang of it. And I don't mean to do it like that and skip steps. First of all, what could I change the square root to? What power? I heard y'all say that when we went over. It's 1/2, right? You can change the square root to the 1/2 power. So this, everything is to the 1/2. So I'm going to put 1/2 inside like the bracket, like all of it right here. So this would be log x plus log y because they're being multiplied. And then instead of writing the 7 right here, I'm going to move it down here. And then I subtract, because it's division, log z. And instead of writing z cubed, I put the 3 out in front. Okay. So I do this all in one step because it just makes sense in my head. I don't feel like that messes with you too much. I guess I'd use 2 steps because you do have to change the square root to 1/2. But then you're doing 1/2 to all of it. So again, just walk through it. I am multiplying the x and the y, so I put a plus. The 7 is a exponent, so instead of writing it there, I drop it down out in front. Okay. Then I divide, so I put a subtraction. And then the cubed is 3 cubed, so instead of writing it z cubed, I put the 3 out in front. Technically, you could multiply the 1/2 through. It should count it either way. Multiplying by 1/2 is the same thing as dividing by 2. So you just write it like this. Could write it either way, but I like to write it the blue way because then I only have to write one fraction. Let me know if Alex doesn't count those, though, please.
I have a question.
Yes.
I noticed this on the homework. I was wondering if you could explain it. So when it's like, instead of xy over z, if it was like x over yz, it becomes...
Yeah, I know what you're going to say. The signs mess with you.
Minus log y minus log z.
So I was thinking that as I was doing that, so that was a good thought there. I don't know if it'll happen on the test, but that's fine. We can do one right here. If I had log, it doesn't really matter. X to the 5th, y. Wait, let's do. Oh man. X, and then I did like y to the 6th and z squared and something like that when you have 2 on the bottom. So again, you do log x. I'm not going to write to the 5th, so I put the 5 out in front. And then I do minus, but here my minus is everything that's being divided by. So if I do a parentheses, I would do log y to the 6. I'm going to put the 6 out in front, plus log z, and z squared, I put the 2 out in front. Okay? So I put those in parentheses so that I can say that I'm doing this one divided by this one. You with me so far? So I have like the numerator on one side of the division, the subtraction sign, and the denominator on one side of the subtraction sign, right? You can, and Alex may do this, you could probably write that as your answer and it would probably count it correct, but you could distribute that negative through, okay? You could distribute that negative through like it was a -1 right here and distribute it to both of those. The other thought process here is you could say that I have this number and I'm dividing by this, and I'm dividing by this, so I have a negative on both of them. I like to think about it the first way and the blue way and say, okay, here's my numerator, here's my denominator, and I'm dividing, so I put a minus in between. And then it's just a matter of what the sign says. Like you can distribute that negative through if you want to. Does that make sense? That help a little bit? Okay. That was what you were asking, right?
Yeah.
Okay. Did anybody figure out which number we're supposed to show on our test work page? It's got to be number 8.
It is.
Okay. So this one is on your test work page again, and this is just a simple equation, so nothing tricky on your test work page to write here. I didn't think there'd be any tricks on there. That's why I didn't pull it up. So in this one, log base x of 6 equals 1/2. When you are solving a logarithmic equation, what you want to do is put it in an exponential. So this says log base x to the 1/2 power is 6. Okay, so this says what to the 1/2 power is 6. The 1/2 is the same thing as the square root. So if I wanted to rewrite this, this would be square root of x equals 6. So what number do I do the square root of to get 6?
36.
It'd be 36. My answer would be 36. If you want to do the algebra, you would say I square both sides. You can even do that from here. You would square both sides, and you'd get x equals 36. Okay. Oh no, I don't want to do that. All right, next one is probably another equation. This is an exponential equation. This exponential equation, I believe, is always going to be, you can manipulate the bases to be the same. So what I mean by that is, couldn't I rewrite 8 squared to be a 2 cubed? Isn't 2 cubed the same thing as 8? So 2 minus 2x, and then 2 to the negative 3x. Now my bases are the same, and once your bases are the same, you can set the exponents equal to each other. Now I distribute here, and I get 6 minus 6x equals negative 3x. Get my x's all on one side, so add 6x would be 3x, divide by 3, and x would be 2. And you can always take it and plug it back in to check your work. So manipulate it to make the bases be the same, and then you can just set the exponents equal to each other. So here we said 2 cubed is the same thing as 8. So let's just write 2 cubed right here instead of 8. And the last one is one of these word problems. The word problems end up being, besides that one I kept messing up, not so bad. So this one says the number of milligrams reaches 7. Well, the number of milligrams is d of h, so this would be 7 equals 35e to the negative 0.3 h. So divide by 35. to get the e by itself. So that's 0.2 equals e to the negative 0.3 h. To get the h down, I'm going to take the ln of both sides. So I take this and this will drop it down. So I have the ln of 0.2 equals negative 0.3 h times the ln of e. Once again, the ln of e is equal to 1. So that just kind of goes away because 1 times anything is itself. And then divide by negative 0.3. So h is equal to ln of 0.2 divided by negative 0.3. Go over to the calculator. Sorry, I can't use my calculator on my iPad because I'll lose my picture. ln of 0.2. If you use the Alex calculator, it's very easy to see this, though. Should be about 5.365. I don't know what it says. It says round your answer to the nearest tenth. So what, 5.4? All right. What it says when it says to not round any intermediate, you could do, instead of doing 7 divided by 35 is 0.2, you could do 7 divided by 35 like that, and then divide it by negative 0.3. So you can, without even doing that fraction and turning it to a decimal, just put it in the calculator like that, and it will give you the correct answer.